In this video, I'm going to talk about relative vector addition using subscripts and how it's just like a chain or a train of dominoes. In dominoes, each tile has two elements to it on the face. There's two numbers on each half of the face. And if one of the dominoes is already played, is already laid down, in order to put the subsequent domino down, the numbers on the faces that are toward each other have to be in agreement. So this 4 on the second half of this face, the first half of the face of the subsequent one has to match. And then once this one's played down, then if you play the next one down, again the numbers have to match. And for relative vector addition, we're going to use the same property, that the elements next to each other have to match. And to do that, we're going to take the vector, and a vector has, for example, this is the vector representing velocity. So I'm having v represent velocity as a vector, and there's two elements to every vector. One is the object. So for example, this is so let's say the green is the object marker. So I'm going to have, so this is my object. So it's the velocity of the object, and my first subscript in this syntax represents the object. My second subscript represents the frame of reference that I'm going to have this object with respect to. So this would read the velocity of the object O with respect to the frame of reference R. So that's what my two subscripts represent: object, frame of reference. And this can be used with any type of vector. For example, displacement, acceleration, angular velocity, angular position, etc., etc., etc. You're always going to have an object and a frame of reference. And now we're going to if we want to add vectors, we're going to add them using the same subscript rules as a chain of dominoes. So rule number 1 is always use addition, never subtraction. If you use addition, then this methodology that the facing elements, the subscripts that are facing each other are going to have to match. But that's not true when I have subtraction. So rule number 1, always use addition. Rule number 2, when using addition, the frame of reference in the prior vector, so that's the second term in that prior vector, has to be the same as the subscript object term and the one that's the subsequent one. For example, this is the dominoes, but kind of just looking here at this would have, for example, a frame of reference S that has to match the object S. So the ones that are next to each other have to be in agreement when I'm using the positive, and I always want to use addition. And so same thing here. So the one that's already played, the frame of reference W, if I'm going to add something to it, has to have the object W. So just like dominoes. And those are my two rules. Now some tips. We're going to have, for our subscripts are going to be singular letters. Make them unique and relevant. Okay, so if it's going to be marker, use the letter M. And if it's ground, use the letter G. And use unique in one so that when you finish your equation, you'll understand what it means. And you never want to make this, because you don't want to have two S's or two, the same, because then you get lost. So make them unique and representative. And you need unique ones for objects and frames of reference. And then when you finish your equations, obviously you're just going to use vector addition, the algebra, in each of the coordinate directions to solve the problem. So if it's displacement or velocity, you'll do it in the x and the y and the z direction to solve the problem. And never use subtraction. Well, we'll talk about at the very end. You can use it with extreme caution, but you're going to first write your equation always using addition. And the only reason you can one of the difficulties with vectors is that so many times we get it wrong because we just get the wrong sign. We get a plus or a minus sign wrong. And part of this confusion comes about, and part of this is good and part of it's bad. So the good thing is if there's a simple relationship between frames of reference and objects. For example, let's say I have marker, there's a lot of red marker, and I'll have the blue ground. And so this would be the velocity of my syntax, always object first, velocity of the marker with respect to the ground, and by definition that equals minus the velocity of the ground with respect to the marker. And just kind of a simple case, so let's say the ground is fixed, and I'll call this the upward, the positive y direction. And let's say I'm going to have my marker move up 1 mile per hour in the positive y direction with respect to the ground. So here I go, I'll have the marker go upward. So I'll put my frame of reference to the ground. So imagine that you have little eyes on the ground, and you're looking up, and the marker is going to go up in a positive 1 mile per hour in the positive y direction. So there it goes. Okay, so that's 1 mile per hour in the positive y direction, marker was switched to ground. During that same moment of time when the marker was going up, if you said my frame of reference was the marker, for example, you have eyes on the marker, and the marker is looking at the ground, the marker to the marker, the ground looks like it's going downward, at 1 mile per hour in the minus 1 mile per hour downward. So again, so with my frame of reference, the marker, the ground looks like it's going down in the -1 direction, 1 mile per hour. So that's kind of this nomenclature helps me with that understanding of how when I switch object and frames of reference, how that works. But we're only going to do that in extreme cases with extreme caution, because we're always going to do addition first. And then if necessary, we'd make that switch at the very end, but you have to do it with extreme caution. Now the fourth tip is when you want to solve an equation, you always want to put the vector term that you want to solve for, so the object and frame of reference that you want to solve for, what's being asked for on the equal side on one side of the equal side by itself. And then all the information on the other side has to add up to that. So now let's have an example that help illustrate that. For example, if I have a passenger and he's on a ship, and the passenger is walking on the surface of the ship, and the ship's in a river, and there's the velocity of potentially of the moving ship with respect to the river or the water, and the water in the river is moving with respect to the land. And my question is, what's the velocity of the passenger with respect to the land? So what I want to do is for each piece of information, I want to use this subscript syntax in order to describe what information I'm given. So the first one I'm given is velocity of the passenger with respect to the ship. So the object's the passenger, so I'm going to put the object passenger with respect to the ship. The second piece of information I'm given is the velocity of the object ship with respect to the frame of reference water. So I use a unique single letter for describe each one. And then the third piece of information I'm given is the velocity of the object water with respect to the frame of reference land. And now I'm asked what's the velocity of the object passenger with respect to the frame of reference land. So now I've written down kind of the vector information that I've been provided. This is what I've been provided with, this is what I'm asked for. So what I'm going to do is I'm going to put what I want. I'm put that on one side of the equal sign. That's what I want to solve for. So I'm going to take I want the velocity. I want to figure out what the velocity of the passenger with respect to the land is. So I on the one side of the equal sign, I'll put I want the velocity of the object passenger with respect to the frame of reference land. And so now on the other side of the equal sign, I need to have, so my object term here has to be the exact same object term in the first term here. So I already know, before I've written anything else, I need to have velocity of passenger, because that has to agree here. The first has the exact same term. So I now have velocity of passenger with respect to something. So I'm going to go back to see what information do I have that I have some information about the velocity of the passenger with respect to some frame of reference. Well, I'm giving velocity of passenger with respect to the frame of reference ship. So now I know my frame of reference term here has to be ship, because I have some information there. And right away, and then you'll look to see, is this frame of reference and my last term here the same as frame of reference here? Well, it's not. I have land and ship, so I'm not done yet. So since I know, just like dominoes, that I have to match again here that the object in the next term, when I'm using addition, and I'm always using addition, has to match my frame of reference here. I can already write, I'm going to have velocity of ship with respect to something. So I can already write that half. I don't know what the frame of reference is yet. So I look at what information I have, and what information I have with the ship. Well, I've already used the passenger in the ship, but I now have ship with water. So there I go. I can use the frame of reference water. So now I've written /water. Then I check to say, is that frame of reference on this term so far, does that match what I have on the end? Well, it doesn't. So then I got to keep going. But I know then I have to have a plus, because I'm always going to add the velocity, and then this new object has to be the same. Object here has to be the same as frame of reference here. So I know I need W for water. So I already can write water. And I go with this dash with respect to something. Well, it turns out I do have velocity of water with respect to land. So now I can put that in there, and then so now I have my equation where I followed my chain of dominoes. Frame of reference object, frame of reference object, and I look, my last frame of reference, does it equal the same as the first frame of reference? It does. Well, so then this equation is complete. This is the correct equation. And so now if I actually have vectorial values for these terms, I can put in there, and I can sum up all the velocities in the x direction, all the velocities in the y direction, all the velocities in in the z direction, and I can find out what my velocity of the passenger with respect to land is. And I'll have no confusion at all. And that is because I follow this chain of domino syntax where the first term, the objects are the same in the terms, and then frame of reference in this term is same as object in this term, frame of reference here, same as object in this term, and the frame of reference in the final term is the same as the frame of reference on this side of the equal sign. In this example, let's say, for example, that instead of given the velocity of the ship with respect to the water, the information was given the velocity of the water with respect to ship. So you switched information provided was the object and the frame of reference were switched. I would still write the problem this way. So even if I had the velocity of water with respect to ship, I still would have said, I have piece of information regarding those two, that object frame of reference pair. I still would have written it this way. Okay? Then there's two ways to deal with it, but you have to do the extreme caution. So you can either, when you're putting in the vectorial values of ship with respect to water, object ship with respect to water, and if you provided water with respect to ship, you can just, in each of the vectorial directions, you can just do the opposite. You can put a minus sign in there. The other way you could do is after you've written the equation this way, but you say, so I've written the equation this way with this subscript, which is exactly like this. But if I was given water as a ship, what I have to do is, using this rule again, I know that water with respect to ship is minus ship with respect to water. So I could take this term I've already have written, and I got to do two things at once. I got to switch the addition sign to a minus sign, subtraction sign, because ship with respect to water is minus water with respect to ship, and I can put it like there. But then you can see kind of my chain of dominoes, kind of, it doesn't work anymore because I don't have ship next to ship and water next to water. See, they flip now, so it makes it confusing. But you can do one of two ways. But if you give information that doesn't exactly, so if your information doesn't follow this, still first write the equation this way, and then correct it, but do it with extreme caution so you don't reverse the minus sign. Okay, now as an example, it works with things other than, for example, velocity. Let's say I had a person riding on a merry-go-round, and that merry-go-round spinning at some angular velocity, but that person is standing and they're spinning, and they have some angular velocity with respect to the merry-go-round. And the question is, what's the angular velocity of the person with respect to the ground? So again, we're gonna put what we want on one side of the equal sign. So I'm asked for I'm gonna use unique letters. So to help me with, what's the angular velocity of the person with respect to the ground? So I have that right there. Now I'm going to use my domino chain rule. I know the first term I want to have here is angular velocity, and I want to have the same object, person. So what I have information about angular velocity of person with respect to the merry-go-round. So I'm going to write the M here for merry-go-round. I'm going to add a plus, and then I know my object here in the second term has to match my frame of reference in my first term. So I already know angular velocity of merry-go-round with respect to what? I'm getting information with respect to ground. So I put that in there, and I look and I see, oh yes, my frame of reference on this side equal sign equals the frame of reference on this same frame of reference on the end of this string, and that chain of subscripts, and therefore my equation is done, and I can use, again, vectorial algebra to solve for this answer. So hopefully this helps you so that we have less confusion, and also I think it's very important to understand that all vectors are relative, and this type of nomenclature with the object frame of reference syntax really helps you just to make sure that you don't make a silly mistake when solving a problem.